Hello everyone, in this video I'm going to show how to do the meshing inside the ANSYS Fluent instead of using the ANSYS meshing. So this is the kinda continue from previous video. The link is going to be shared in the explanation or definition of this video, and also I will put some notes on the video you can see on the right hand side top corner, so you can refer to that video. I will go like fast what I did before. So I created um, some flow domain from the diffuser, which creates a swirl flow. Then after extracting the flow domain, I created the cylinder on top of this one to consider as the like inside the um, no, a room, as a air inside that room. So what I did before, I created inlets as the inlets here uh, on the side walls, and I created the outlet here, and I created the side wall as this one here. So I created the name selections here because I don't want to use the ANSYS meshing. First I will export this geometry. So I will go like geometry to Fluent, just use the AGDB, the, the, the default format, and I will export this one. Then I will open the ANSYS Fluent and show how to do the meshing and setting up the problem inside the ANSYS Fluent. Now I have exported the geometry. I will run the Fluent here. So the very important point is that if you want to do the meshing inside the Fluent, you can't do through the ANSYS workbench. You need to run Fluent separately and to see this meshing option here. So I will choose the number of processors, everything I need here, and click start, but make sure that you are not on the solution mode, you are on the meshing mode, so you can see the number of the meshing. And I will click on the double precision, and this is the 2D by default. I will start this one here. So Fluent has two types of views. One is the outline view, one is the workflow. Workflow is pretty easy to work with because it will, as you will see, that it will show you like the steps you need to take. So it's very easier to follow. So I will use watertight geometry. Click on the import geometry, select the file. So I copied the address of the file I had. This is the geometry I exported from the design modeler. I'll click OK. So it will take a while to import the geometry to Fluent. So Fluent meshing is getting better these days. So personally I use the Fluent meshing more. I encourage you also use the Fluent meshing more, especially if you are new to CFD and want to learn just getting started with CFD. So with the Fluent, ANSYS Fluent, it's easier to get a better mesh. So this part is the add local sizing. I will choose no, but you can choose yes, and for example select one of the for example inlets and specify some kinda local sizing for this one. But if you select no, it will follow the global sizing. So Fluent has a good suggestion on the minimum and maximum of the global sizing, but I will create surface mesh, so it has the same options as the ANSYS meshing here, like the curvature, proximity, curvature angle, number of the cells in per gap. So I will for example change it to 2 if you want to. So, and if you click on advanced options, you can see more options here. Maybe I will go through these in more detail in next videos on the Fluent Meshing. So create the surface mesh. The good thing is with the Fluent Meshing, it will show you the mesh metrics. Two main parameters about the meshing is one is the skewness and the other is orthogonal quality. For the surface meshing, it will show you the skewness at the end of the surface meshing. I will show you the number. So the good mesh will have a skewness less than 0.7 or let's say 0.8 if you have a very like complicated geometry. So the maximum skewness is 0.58, which is very good. But in case you got a bigger number, let's say you got 85, 90, you can right click here on the surface mesh and insert task and improve surface mesh. Then it will give you the option. Let me add this one. So it will give you the option to define your goal maximum skewness for the surface mesh. So I will delete this one because we have a good quality. So next is the describe the geometry. So our geometry consists only from fluid with no voids or dead boundaries. Okay, so I will click this one, change the fluid boundary types from wall to internal. No, I don't want to do that. Do you want to apply shared topology? No, because we have just one single domain. So describe the geometry. Then update boundaries. So these are the name selections we defined in the design modeler. So you can also select here and give the names and everything you want, but it's easier to do that in the design modeler. So the inlet is the velocity inlet and sides are wall, outlet is pressure outlet. So I will keep as is, update boundary. Then we have a one region which type is fluid. You can change it to solid or dead, which will not go to the solver. So update region. Okay, so you can apply boundary layer. What's boundary layer? These are the for the walls. Let me. So on this one, we can go to the selected zones instead of on the walls. I will just show you what's the difference. So I will click side walls only here. So and click boundary layer. I just want to show you the results and what's the difference here. It's a very important option. So I will go and just create a volumetric mesh. I will go back to boundary layer because of that, and then I will explain this volume meshing later. So what does the boundary layer do? You specify the walls you want to have the inflation layer. So in the Fluent, the default setting is to create inflation layer on all of the walls unless you specify some of them. For example, you have some parts that you don't care about, and it's not important for you, so you don't need to have inflation layers there. So in that case, it's less expensive computationally to just avoid adding inflation layers to that walls. So I will wait until this is done. It will take a while. So it's creating as the default mode, it's creating polyhedra mode. So polyhedra is kind of one of the best options for fluid bodies. So if you have an external flow, for example, if you have a car in a wind tunnel, or it will be different. So you can use the mosaic shape, so you can add polyhedras near the boundaries, and like cubic shape meshes far from the boundary. So I will try to create a video to explain those different meshing options inside the ANSYS Fluent. Okay, now our meshing is done. So it's kinda creating this clipping plane automatically, and you can click on the draw cut cells, so you can see inside the mesh very nice polyhedra mesh here. So as you can see, there's no inflation layer near these walls, but if you go to the walls we selected, we have like 3 inflation layers here. Then it got larger size of the mesh. So I will go back and delete this boundary layer. Yes, and it will delete the volume mesh. Okay, so I will select, do you want to add the boundary layer? Yes, and only walls, so it will create this inflation layer on all of the walls beside the inlets and outlets. So I will keep this one as the default option. So you can select the number of the layers you want, 5 layers, 3 layers, depends on your problem and the accuracy you are looking for, and the Y plus on the walls, and those kind of considerations. So add boundary layer. So the method is smooth transition, but you can select the other options like ANSYS meshing. So I just wanted to show you how to do the meshing in this video. I will try to create a very detailed video on the fluent meshing. So you have different kind of tetrahedras, hexacores, polyhedra, and polyhex-core. So I will go with the polyhedra meshing, growth rate 1.2. The maximum length is 20 millimeters, 20.23. So I will just do the 20, and you can create advanced options to see different advanced options. And just for most of the problems, you don't need to change any other advanced options, and you can just follow the default values, which is very good, especially on the latest version. So I will click on the create volume mesh. So I will pause the video and come back when it's done. Okay, now the meshing is done. It shows the minimum orthogonal quality is 0.05, which is low. So I will insert improve volume mesh, like I will put 0.15, and click on the improve mesh. So Fluent will try to improve the mesh quality. Most of the time it will be successful, and we will reach the quality we are looking for. But sometimes when you have a more complicated geometry and you can't reach the quality here, you need to go back and modify, for example, your surface mesh, or clean up the geometry, look for sharp points, look for inflation layer, minimum and maximum size of the mesh. These are different type of the parameters you can go. So now it's done. You can see that by very small changes, and it's done very fast. So by some changes during the meshing, which Fluent automatically improves the mesh, and our final minimum orthogonal quality is 0.15, which is acceptable. So if it's 1 is perfect, so more than 15 or 0.15 or 0.2 is very good. So one thing that you can slide this bar here and go through the mesh, or you can change different limits, or z limit, which is same as the x here. So you can slide this one and go through the geometry to see how is the mesh inside the geometry. So you can see we have a finer mesh here. As we go up, it kind of the grain size is growing, and we have a more coarse mesh closer to the middle here. So always write the mesh before switching to the solution. So I will just keep this one. The good thing is about the why I ask you to always export the mesh, because if you want to do some changes on the mesh, you can open the Fluent again and read the mesh here, and you will see all of the tasks you have taken before, and you can go back and modify something here. You will not have just non-editable mesh file. So one way to do just switch to the solution. So I will click here, and it will ask you if you want to do that or not. I will click yes, and it will just switch to the solution mode inside the Fluent. So it will kinda close the meshing mode and open the regular Fluent where we set up our simulation. One way is this one, and I will show you the other way how to if you want to work on the workbench, which is I prefer to work on workbench. So you can click on the display and display the mesh here. So this is the one way. So you can bring the mesh here and set up the boundary layers and everything inside the Fluent. What I like more to do is to work with the workbench. I will drag and drop a Fluent block here, double click on the setup, and choose the number of the processors. Okay, here you can select on the import mesh, yes. Go to the mesh we have exported from that other Fluent window and click OK to open the meshing here. So I will go ahead and close the previous Fluent and work on the Fluent window I created in the workbench. I just wanted to show you that you can do this here and save your files, but it's better to work on the workbench, so you can export the results to the post-processing or CFD post easily. So it's reading the mesh now. Okay, the mesh is done. From now on, it's exactly the same as the previous video, just but I will go through this one. So in this new Fluent, the default viscous model is SSDK omega. I will change to laminar because I wanna have a very fast simulation. But you need to make sure to calculate the Reynolds number and make sure what's the type of the geometry. And the SSDK omega model is one of the best models for engineering applications if you don't want to deal with the wall function, and it predicts better. So I will keep the material as the air, so I will click on the fluid and make sure this is air. Okay, let's click OK here. So I will open the boundary condition inlet, which is velocity inlet. So in the previous video we did 1 meter per second. I will click OK and I will initialize. Okay, initialization is done. Then I will go to run calculation and 200 iterations and click on the calculate. So I went through this simulation in details in the previous video. I just wanted to show you how to do the meshing inside the Fluent, which has improved a lot during this the new updates of ANSYS, especially 2020. So you can refer to the previous video for more details on the problem, and also some documentations I shared in the link below the description of that video, and about the post-processing. I will pause this video here, and when it's done I will come back and show you the results. Okay, now the calculation is done, so I will go ahead and plot the path lines. So from the inlet, colored by velocity and velocity magnitude, I will click display. Okay, so it displays the velocity magnitude path lines. Here you can see that we have the swirl here. So for more details on the post-processing, please refer to the previous video. I will not go through that again. So I hope this video is helpful. I will create more videos on ANSYS Fluent meshing because it's getting better and better, and I think switching to Fluent Meshing will be helpful. So thank you for your time, and thank you for watching this video, and please subscribe to our channel, like our videos, and put some comments if you have any question or if you have any specific problem in mind, and thank you so much.